Hey, what's up, everybody? This is Andrew.
And this is Chris. Welcome to our weekly stim. It's Father's Day. I got my dad's root beer here. Andrew, you celebrating Father's Day in your own way over there?
Yeah, I got my fur baby, so they left me some fur and a little bit of mess to clean up. So
We love you, Daddy. Here, have a present.
yeah. How's your week?
It was good. Very very busy. A week for actually finding out some really cool things going on both career wise and with a bunch of other friends here. So um, uh, hopefully we'll have some new news coming up soon.
Awesome. Good luck.
Thank you very much. How was your week? How were all the fun things and getting ready for, of course, your trip down to Cape Canaveral, but all the fun stuff. You had some unboxing that you did this week.
Yeah, we did I got a new 3D printer. I was hoping to finish it last week, but I'm like 95% done. It shipped without instructions, so it was like almost impossible to figure out what was going on. We're basically looking at pictures online of an assembled unit, and we're trying to figure out how to assemble it from these pictures. We've probably already spent like 8, maybe 9 hours on it already, and we're almost done. But yeah, we did an unboxing video, and we're doing an assembly video as well. So those should be going online probably in a week after we finish it, and we should finish it tomorrow. So hopefully that's going to happen soon. Did
So
a
what's the first thing that you want to print as soon as it's operational?
Well, I guess the standard for people, what they do on a 3D printer is they print a cube that's like 20 millimeters on each side. I think that's kind of boring, but I guess it's like sort of the standard or whatever. But I think I'm going to print a 3D version of the Hello World sort of like thing that computer programmers usually print on the screen each time they're like write like a new program. They'll say Hello World. So I'm going to try and do a 3D version of that.
I wonder if instead of printing a cube, if you could actually print a die that actually has the a hole cut out for each of the each of the digits that are on a dice face.
Yeah, you could probably do that. I think the face that would probably have the most problem is the one that's facing down, but I don't see why.
Just make that the one, and then you just do a little circle, and it builds up around it.
Yeah, yeah, that could probably work. Um, and then we did a video with Nico from Museum of Science Fiction, so we'll be there in a couple weeks. July 4th weekend in downtown, well, not downtown DC, but near downtown DC in Maryland, right across the river from Arlington. They're going to be doing a science, technology, engineering, arts, and math event called Escape Velocity. So if you guys are watching this video, check out that last video. It's the one that's right before this one. It says Escape Velocity. Check it out if you're in DC. It's going to be an awesome event. So yeah, we're going to be getting ready for that, and it's going to be a lot of fun.
Very cool.
Yeah. Also saw Central Intelligence yesterday, the movie with The Rock and Kevin Hart. It was really funny. So if you guys haven't seen it yet, go check it out.
I'm actually planning on seeing it this afternoon. Lucky for me, for Father's Day, my wife said, "Okay, you can have a day to yourself without the kids." So instead of spending my day with kids, I'm actually going to go watch Central Intelligence, which I'm highly looking forward to.
Yeah.
Well, awesome. Well, why don't we jump into our topics of the day? I think you're leading us off with a science story.
Yeah, so for our science story, we're going to be talking about Juno. It's a spacecraft that's on its way to Jupiter right now. It should get there July 4th weekend, so that's like an extra reason why I think it's going to be really cool at Escape Velocity. July 4th weekend is because there's going to be a spacecraft arriving to a planet at the same time. So yeah, Juno is a spacecraft that is on its way to Jupiter. It should get there in a couple weeks. It was launched back in 2011, so it's been on its way for a while now. But as we know, light travels very quickly to get to places in the universe, relatively speaking, but spacecraft not so much. So it was launched back in August 2011, so it's taken this 5-year journey to get to Jupiter. And when it gets to the near orbit of Jupiter, things are really sort of critical. That's like a really critical part of the mission because you have the spacecraft which is traveling, thousands of miles an hour towards this huge planet, and now all of a sudden you got to like slow it down and have it start orbiting Jupiter. So it's a lot of stress for those NASA engineers and flight directors and everything at that point.
How long does it take a signal for the mission control or the people here on Earth to send a command to to Juno?
Let me Google it real quick. How many light minutes away is Jupiter? Bum, 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 bum. 5.2 minutes. So it takes 5 minutes approximately, or 2,595 seconds to get a signal from Earth to Jupiter, traveling at the speed of light. So if you know, we're about 8 light minutes away from the sun. So if the sun blew up or whatever, we wouldn't know for 8 minutes until the light traveled to us. So yeah, it's going to be really hard to. They're not going to be able to sort of do anything in real time because of that delay. So it's 5 minutes one way. So it's 10 minutes to basically send a command and then like find out what the response was, that sort of thing. So they can't really do like real-time navigation. They'll have to rely on the computers on board and all that sort of stuff. But the Juno spacecraft is going to be really cool because it's going to be measuring the different layers of Jupiter. So the primary sort of thing that we think about Jupiter is that it's a gas giant. But there are theories of what's underneath the sort of most exterior layer of gas. So they're thinking that there might be water in the atmosphere, and they think like at the very, very core that there's a hard rock center. So Juno has special instruments on board to peer in past the dense gas of Jupiter and measure all these different materials and things like that. So it should give us a good idea and peer into how these planets are formed, these gas giants, and what exactly they're made up of. Because right now we just see gas. So it'll be cool to see exactly what types of gases and what's in the center. Is it nothing? Is it a big rock? I think it's a big rock, but yeah. So Chris, I guess my question for you is, if you could know what do you want to know about our solar system that maybe is not already known? Like, is there life on Europa, or what would you want to know and that sort of thing?
I'm actually interested in a lot of the geology and similarities between certain planets and Earth. So I want to know, there's speculation that perhaps Jupiter is volcanic, and has operating volcanoes which are spewing out all these gases and contributing to the atmosphere. I'm curious if that is the case, if Jupiter is volcanic, what that means for similarities of other planets. Do we have volcanoes other places? Does that mean that geology on some of these planets is similar to geology here? Also, what lies beneath the surface? I guess is it just a solid rock, or all these planets actually constantly moving and changing and shifting based upon internal geology, not only just the external, but subcrust activities. That's something that interests me. I could care less whether there's life on another planet. I think we've already ruled that out on our planets. And in fact, this week the scientists said it might take us another 1,500 years to actually communicate with anybody from a distant galaxy, even within our own galaxy, if there was some sort of life within the Milky Way galaxy. So I'm not worried about the life side. I'm just more interested in geology, and then what if there are geological similarities, what kind of assumptions can we make about Mars or Jupiter or Neptune or any of the other planets in our solar system about making fuels or using materials from those planets for for our own uses.
Hmm. Yeah, that's a good point. Because one thing that'd be kind of cool is like if we wanted to somehow visit Pluto someday, if we could like make a pit stop at Jupiter and scoop up some gas and use that for fuel, that'd be pretty cool.
Having I look at it this way. I don't see us making a warp drive anytime in the future, and I see us needing fuel, some sort of fuel. Right now, we're focused on a combustible fuel, and if we need to have combustion engines, then we're going to have refueling stations. I fully expect Shell or Mobil or Texaco to create a refueling station for space exploration in the next several hundred years. I think that's where the petroleum industry is going to look. If they can't look below the Earth's crust, they're going to look below the crust of other planets. And then what does that mean for uh, outer space exploration?
Hmm.
How about yourself? What would you want to find?
I really want to know if there's life on Europa. There's a strong possibility. It's a ice moon of Jupiter, and um, it they're pretty sure that there's liquid water underneath, and there's the only way that there's liquid water. This is pretty interesting because they call it the Goldilocks zone, where planets are in a solar system, not just necessarily our own, but where liquid water can exist. Because if you're too close, then it boils, and if you're too far, then it freezes. So um, that's sort of the reason why Mars doesn't have any water anymore. It partially has to do with where it's located, but also the fact that it has a very thin atmosphere, so it escaped through the atmosphere. But so they call Earth and like other planets in Earth-like orbits, they call them the Goldilocks zone because liquid water can exist there. But that's because of temperature, right? But on Europa, it's getting gravitationally pulled in different ways by Jupiter, so it's causing this friction. So if you basically shake a bag of ice for a while, it's going to turn into water because you're converting all that energy into basically heat that's heating up the ice and it melts. So there's a really strong possibility that there's life there under the surface, and because they think that life could have been brought to Earth on meteors and stuff like that. So if they've been hitting Europa, it's a good possibility too. So yeah, definitely a probe to go ice fishing on Europa. That's what I would.
Set up a little cabin to have a couple of cases of beer, drill a hole, and see if you can catch a fish.
Yeah.
Very interesting. Well, our tech story today actually is a little bit more terrestrial. It's actually looking at Facebook. The past week and a half, Facebook has introduced 360-degree video and VR capabilities, so that anybody can now take a picture of, say, the Grand Canyon and do it in a 360-degree arc and have that translated into something that everybody can experience and look around and create a 360 still photo but video that you can now navigate around. This week, actually using that, the Associated Press decided that with many people now focused on virtual reality or immersive experiences, is it possible for us to create news broadcasts or to deliver the news in a way that makes sense for consumers? That means testing 360, that means testing virtual reality, and seeing how consumers interact with it. Do they just look around? Do they try to reach out and touch the objects they're looking at? But also, what creates a more immersive environment that people can connect to? The odd thing that I found in the Associated Press findings is that they say that 360-degree video or 360-degree images for news stories are actually much better at providing the news and getting it in a realistic way for consumers than VR was. Partly, one, because of having to create virtual reality. It's expensive, it takes a lot of time. But secondly, having something still that people can see and experience ended up being a lot more reactive, that people could actually, it's more tangible. It's not like being immersed into something that's artificially made, but it's actually, I can see it, I can understand it, I can feel it. My question to you, Andrew, is you had the chance, you have the Samsung Gear headset, and you had the chance to actually go outside and create some 360-degree looks of your neighborhood and maybe a few other things. What was your feeling if you were a newscaster? Would this be a tool for you to help explain a news story, or is this something that you think might be a distraction in terms of being a news person?
I think it would depend on the situation. But yeah, so I got the Samsung Gear 360. I don't have the camera with me right now, but this is the box it came in. They haven't been released yet. Did an unboxing and review of this, so go check out the video for that. But it's a pretty cool thing, and I think you're right. Like in terms of news and stuff like that, I think it'd be better to get a 360 experience in a VR. And it sort of depends on how you have your, like one thing I learned about doing a time-lapse video while we were doing the unboxing of the 3D printer was that we basically put the camera in the middle of the room, but like there was only action going on in one specific area. So the time-lapse is kind of boring when you look at the room, except for where we're doing the work. So I think the camera placement is very crucial. Because otherwise, why not just do a regular 2D sort of like look? So if they could have like the news broadcaster like on one point of the camera, but then like have the action like on the reverse side or like that sort of thing, then I think it would be really cool. Where you could, if you want to look at the newscaster, you can pan over to newscaster, like watch him talk, or you can pan back and like watch maybe if there's like some speaker delivering a presentation or something, you can watch that too. Most of the demo 360 videos that I've seen, like in my VR headset, they have action going on all around. So I think that's sort of like where 3D comes into to play in terms of like news broadcasts and stuff like that.
Yeah, I'm curious, for a news broadcaster, a couple of things are crucial. I mean, one is delivering things in real time, right? You want to be able to do as quickly as possible or as in real time as possible, not only talk to your audience, but allow your audience to see what's going on around you. So, for example, if I'm going to be reporting on a crime that had happened, if I was able to set up the camera as close as possible to the police line, to the yellow tape that's going across, set up my camera there so people can see that the police are investigating, or there's a chalk outline, or that here's the crash, and you can see the rescue workers working, and then I'm actually facing, as the newscaster would be, on the other side of the pole, facing the pole. So that you can turn around and I can be looking at you, essentially the audience, as you spin the video around. I can be looking at you, reporting the news and reporting exactly what I'm seeing or narrating what I'm seeing, while you're also have the opportunity to turn around and see it for yourselves. So I think like for reporting some things, it might be beneficial, and it gives people the opportunity to kind of look around the scene and see it in full view. But for news reporting, that there's not much that's needed in terms of immersion. I believe you watched the keynote from Mobile World Congress from Samsung, and Samsung tried doing a whole VR experience so everybody could see it in 360 and experience it in real time, but it was laggy, and it ended up being really kind of a gimmick.
That's the thing with VR now too, is like with the stuff that you can live stream with and things like that, like the quality is not great. The resolution of the camera, let's see if it's on the box here. It sounds really good. 3840 by 1920, so that's almost 4K, right? So you have like a near 4K camera. However, it's 4K spread over a sphere of 360 degrees. So any one point is less than 1080p. 1080p. So I mean, it's like, it's still not high quality. So yeah, when I watched that Samsung event where they where they revealed the S7, I ended up switching just back to the normal view because uh, the, you could hardly even like make out someone's face. The only really good stuff that I've seen so far with like 360 in terms of quality is when they do the GoPro stuff. Have you seen these like mounts?
Mm-hmm.
GoPro? So they have like 6 or 8, or I forget, GoPros like mounted at different angles, and each one films a different angle, and then they stitch it all back together. So those videos are amazing because each camera's point of view is 4K. Then you stitch that all together, so you get a really good video. But yeah, the stuff now it's just like the single cameras, like the quality's not so great. The pictures are okay, the videos, but it's still cool.
Mm-hmm.
Like Chris
I
said,
think I think for print media or online media, it'd be really cool to have kind of this 360-degree video that you, or at least picture that you could navigate through and see, a crime scene in full 3D and put that onto, Washington Post's immersive view, whatever you want to have there. Read the story and then click through the crime scene if you want to, or click through the sporting event or whatever it was that was being reported on.
yeah. And camera placement is crucial.
Yeah.
So, yeah, we're going to be finishing up the 3D printer tomorrow, and I'm just trying to think of where I should place the 3D or place the 360 camera. I think I'm probably going to place it like right by me or something, just so that there's more stuff to view or whatever. Or I might just put it back in its original position so the time lapse is sort of seamless or whatever. I probably don't want to mess up the view, but yeah. So.
Put a cat tree on the other side, so when people are bored looking at you, they can look at the cats climb around.
One cool thing I found out about the camera is that it has like a stereo microphone on it or whatever. So like it can like if the camera is staying still and you're watching a video, if someone was like walking around the camera and like talking, you hear that sound being, from your right ear and then like going to your left ear and stuff like that. So I did know that was gonna even be included or whatever. So that was a nice surprise that it's more that immersive experience. And
well, that, and then you get to find out what it's like to be tall.
Yeah. So thanks, by the way. But yeah, so I told Chris I took a picture of the inside of my kitchen, and I have this monopod. If you watch the video, you'll see the monopod that I have for this thing. And I basically put it all the way up, and it probably stands a little over 6 feet or something, and I took the picture. And then when I was looking at the picture with my VR headset, it was kind of amazing because like it was my house, but I was seeing it like about from a foot taller, and I'm only 5'7", just about, so I'm pretty short. But I could see like the tops of the cabinets, and like I was like, oh man, I can reach all the way in the back, and like everything like looks so much like smaller looking down, and so it was like experiencing life as a tall male, as I've never got to do before. Pretty good experience.
Well, and then the sad part is when you do that in your kitchen, then you see all the dust bunnies that have collected on top of the cabinets, and places where the cats have not laid down to collect and clean for you. So it's just more stuff to clean later.
All right, so now we'll move on to our engineering stories. So some pretty exciting news from the people at LIGO, which is the Laser Interferometer Gravitational Wave Observatory. There's 2 observatories. There's one in Washington, and the other one, I just had a brain dump. The other one is Louisiana. And so about 4 months ago, they announced that they detected a gravitational wave. So for those that didn't see the first story, gravitational wave is basically the aftermath of 2 black holes colliding. So black holes, are those mysterious things. They're so heavy or whatever, but every once in a while you'll get two that are near each other, and then they kind of like eventually like spiral and get really fast, and then bam, uh, um, merge together. And the interesting thing about black holes colliding, you think like, oh, there's an explosion, like if a star died, like when it becomes a black hole. No explosion. Um, but there's a ton of energy released. So there's the two black holes each have a certain mass, really heavy, and then so some of that mass is converted into energy, which is in the form of this gravitational shock wave. So most people are uh, familiar with the like a sound shock wave. So like if you see um, sometimes you see like on a video like a big explosion, and then maybe 10 seconds later you'll see like this sort of like shock wave propagate through the air and like maybe rattle windows or like set off car alarms, stuff like that. So gravitational shock wave actually bends space and time. So as some of you know, general relativity is Einstein, my guy right here. Einstein explains, some of the ways that things are happening with because of general relativity, and so we think that, uh, we came up with the explanation for the rotation of the solar system and galaxy and how everything orbits according to Newtonian mechanics, but it's basically general relativity is the reason why. So mass, which is stuff in space like planets or stars or whatever, they bend space. So if you think about a bowling ball sitting on a sheet and you drop a marble on it, it's gonna roll towards the bowling ball. So that's sort of like the layman's explanation of general relativity. So these shock waves come out, and since space is made up of space and time, so your space-time, it bends it a little bit. And so they detected they announced the detection of the first ones in February, and they just announced this week another detection. These detections were actually last year, but it takes sort of this long to go through the data and to verify everything. So the detection in February actually occurred in September of 2015, and the one just announced was in December of 2015. So, but they have to sift through all this data because and this is the reason why they have the two observatories underground, is so that one can sort of complement the other, and if they both detect the wave, then it happened. But if it's just like minor fluctuations in the instruments, then you wouldn't know if something actually occurred or not. So what's really amazing is that they're able to the detection range for this thing. So when I talked with DJ Patel a few weeks ago at the hackathon, he was asking me about the LIGO thing, and I didn't know the detection range, so I made sure when I was researching the story that I found out how much exact deviation are they detecting, because it's basically this laser light that passes through some mirrors, and then when the gravitational wave goes through, it lengthens one mirror and shortens the other, and then they're able to, when that laser light gets recombined, they're able to tell how far they were bent or whatever. And it's like the tenth of a size of a proton or something like that. Like that's the detection range. So it's smaller than a proton. So think about the engineering that has gone into these observatories to detect the deviation of something smaller than a proton. That's crazy. You can't measure that with a tape measure, which is why they use these things called interferometers, because you're able to detect these subatomic sort of scale things. So that was amazing. They think they got another one that occurred in October, but they weren't able to sort of get out the data as clean as it should have been. So they didn't announce it as a gravitational wave, but they think there was one, but they just can't. They don't have enough confidence to say that is. What's interesting about the new one is that the black holes that were colliding were pretty much small. So the two black holes, one was about 8 times the mass of our sun, and the other one was about 14 times the mass of our sun. So 8 plus 14, 22, right? The new black hole is only 21 times the mass of our sun. So a whole mass, a whole sun mass was basically converted into energy in this shock wave. These are the masses that the scientists sort of expect to see often. The first ones that were detected or announced in February, they were huge. They were like 30 times the mass of our sun, so they didn't really expect that. And me and Chris were talking earlier about this. One of the interesting things that they can do is, since these are waves, they can convert them into sound waves, and you can go online and click the link below and yeah, and listen to these things. So they actually sound just like the sound that Chris is doing now. Go ahead and do it, Chris. Yeah. So if you go online, they sound just like that. The new one actually lasts like a second. It kind of like builds up and then does that little chirp thing. So yep. So yeah, Chris, you could be a gravitational wave impersonator.
It's always been a career of mine to do voiceover work and sound work. I never, for the life of me, thought it would be doing sound effects for physics. But astrophysics is a burgeoning field.
All right, so I guess my question for you would be, what would your stage name be for your science voiceovers?
I don't know. It's funny you should ask. Actually, I was looking up during this week. I was looking up uh, famous people who have degrees in STEM, and one of the people that I found out actually has a PhD in astrophysics is Brian May from Queen.
Uh,
So yeah, he from the band Queen, he has a PhD in astrophysics. So maybe I would have a stage name paying homage to Brian, maybe or just Queen in general. Maybe I'll do Brian Mercury or something like that. And pay homage to a physics voiceover artist.
cool.
I find it interesting that the exact deviations are so tiny that you're finding between the two different sites. One, the site in Louisiana and the site in Washington. A tenth of the size of a proton. Anybody who's seen the movie Ant-Man, not to say that Ant-Man is actually 100% accurate in terms of the depiction of the science, but there's a portion in there where Ant-Man gets smaller and smaller and smaller, and you can see him next to all the different protons and electrons and other subatomic particles. And it's just really an illustration of how small things can get until you kind of disappear into nothing. And so it was, the tenth of the size of a proton was even smaller than what Ant-Man's getting in the video or in the movie. If you've seen the movie, that size is just, or that lack of size. It's just mind-boggling to me that two places can have the exact same result. It's like 0.0000 to just keep on going. In terms of the size and the value in the difference between the measurements there.
Yeah, and so what's interesting is like that like that's their detection range, but they're not actually like measuring that like with a stick or something. They're like when the laser gets like sort of recombined after these mirrors, it sort of like automatically gets magnified into like this atomic scale thing. And so when you deviate slightly, like it sort of like deviates way more on this like magnified sort of thing. So it's kind of like looking through binoculars or something into like an atom. But it is still amazing that we've come up with the technology to do that. So
now, given that these are waves. I mean, these are things that actually you'll see an arc or a cosine type of pattern, um, and it's a wave between space and time and that release of energy. Is it something that you can sit there and say there's a way for energy to surf that wave, or for us to see a change in the shift in time, time space, things getting pushed as a result of this gravitational wave? What are the implications there?
Well, I think in terms of the ones that we detected, like it's detected on the scale of something smaller than a proton. So technically everything on the Earth was like shrunken and lengthened by something the size of a tenth of the size of a proton. So the implication is very small there. And then with time too, it's going to shorten and lengthen the ticks of your clock during those waves as well. But again, if it's something that's small, it's going to be almost you won't be. But if I think where implications would be larger is if you're near this event. Now, I don't think that we would. I don't know what like the closest black holes are, and you would basically need a binary black hole or like a binary and a neutron star to collide. But you would have to be near these events in order for there to be like a huge thing. Because like let's say there was a planet near this thing, you know, that'd be crazy because you would have this like obviously if you're like near a sound shock wave, like it's going to be pretty heavy at the beginning, but then it dies out. So it's the same with these. Imagine like you're getting like 20 feet longer at one point. Like that'd be creepy, you know? But
might be painful too.
What's that?
Might be painful too.
Yeah. And then I think while you're getting lengthened, timed would be short. No, lengthened as well. So when you get short, time ticks slower for you. That's how usually how it goes. So yeah, it would be really weird if you were near these things happening. But yeah, for us on Earth, we're pretty safe.
Well, I think that we're absolutely safe, but I find it interesting that the amount of energy that's released. I mean, if you've seen Star Trek, where the singularities happened in the first reboot movie, and the Enterprise is getting sucked into the what happened in the collapsing of the black hole. The amount of energy that's also produced, not only in terms of sucking in, but that coming out. I think it's just amazing when it happens at the spot. Black holes are nothing nothing to mess around with when it comes to energy. Not only the amount of energy it draws in, but the amount of energy that can be expelled, even if it's only the amount of one of our stars. For comparison, the amount of energy that our sun expels is pretty outstanding.
Yeah, and our sun's been around for 4.5 billion years, and doing and it's still going, and it's gonna be going for another 5 billion years or so. So I mean, like,
knock on wood.
Imagine all that energy that's been powering, the Earth and been able to like do all this stuff. All that energy, boom, gone, and like a snap of a finger, it's been released. So pretty amazing.
Well, why don't we jump over to our math story of the day? And our math actually kind of has a little bit of something to do with space as well, and Star Trek, which is why I brought it up. Andrew, you are quite the Trekkie. What were the Klingon birds of prey famous for?
Oh, I see where you're going. I was gonna say, I don't know, bad smell, blood wine. There's a lot of ways you could go with this one. But the Klingons had a really good technology called cloaking.
That's right. They did indeed. Ding, ding, ding. 5 points to Mr. Denio over there. Scientists actually here for a couple of years ago have figured out a way to actually create cloaking devices. And what cloaking is actually some technologies call it active camouflage, where you're actually mimicking exactly what's behind you. But cloaking is actually making something completely disappear by changing the way that your eye actually sees the light and what it's reflecting off of. And if I'm able to, say, take the front of my body or take my car, I wish my car had a cloaking device so the cops wouldn't catch me. If I was able to have a projection of everything that's actually behind me, you wouldn't be able to see it. The problem, however, for a number of years has actually been the geometry of cloaking. So if I were to take something that looks one way, and if you have seen one of the recent Mission Impossible movies where they break into the Kremlin, they actually put up a sheet that has a camera, and it, on the back side and on the front side, it projects exactly what you see down the hall. The problem is if you change your viewpoint, well, then the actual projection is going to change as well. You don't get an actual look. If I'm looking down a straight hallway and I turn my view, well, that view is actually going to be skewed based upon where my eyes are looking. It's not actively tracking where your eyes are, and the camera is not shifting that field of view. The scientists have found or mathematicians have found new breakthroughs in the geometry to make cloaking much more realistic, so that wherever you're looking, it ends up much more accurately showing exactly what's behind it, and having a more accurate cloaking, or making everything that much more invisible. Andrew said this earlier, that camera placement is crucial. And if for the GoPros that are mounted at very different angles, and the same is true for any sort of cloaking or active camouflage setup. So, Andrew, my question to you is: if you had the capability to have active camo or a cloaking device, where would you go? What would you cloak?
That might get me in trouble. See, what would I cloak?
Remember, we're a family-friendly show.
Yeah. Um, I don't know. Do you know? Do you know what you would cloak?
I would want to go someplace that would be off limits to the general public. I would love to be able to go um, to the face of Mount Rushmore, to some sort of wonder of the world, where we're not supposed to set foot on it. We're not supposed to go there. And if we're able to, or the forbidden or the Forbidden Palace in China, some of the places where we're not supposed to set foot in. I think that would be interesting. I want to be able to take in the sights. I would love to be able to, have the Harry Potter-esque, blanket to throw over myself, um, but have kind of that active camo. You can't see me there, but I can observe and see everything that I'm around.
Yeah, I think it'd be cool to like go in like the wildlife sort of thing, like go on a safari, but just like, you would want to hide your smell too. But if you could do that, walk among elephants and lions, and like they can't see you. Like how cool would that be? Just hope they don't accidentally like start playing near you and like scratch you. But uh, that'd be cool to be among those creatures and like not really be scared for your life.
Or not have them scared for their own. I mean, there's a lot of things in nature that they see what they perceive to be a predator, and they'll run away. It doesn't even have to worry about the smell. So I think that's cool, actually. Whether it's being in nature, being in some place where you can't be, but just being able to enjoy and view something that you normally wouldn't have the chance to do if you were seen to do it. I think that's awesome.
I think I could see like huge applications, like of course in the military for cloaking, cloaking vehicles, cloaking soldiers, that sort of thing. Cloaking,
Spy plane.
I think cloaking buildings would be pretty cool.
if you never knew that the building was there, the only way you'd find out is if you ran into
Yeah,
it.
throw a rock and it like bounces off a cloud. Like, what was that?
Hey, that wasn't supposed to happen that way.
Yeah. Um,
Oh,
one thing I'm really interested in, I guess I don't know if it really has to deal with cloaking, but is holograms. I don't know. They're two optically difficult problems to solve. Hiding something and then creating light in out of and shining it on nothing, but having the picture show up there. Two really difficult problems in optics. Uh,
well, and to have the image be, it's not only just the optics of displaying it, the viewer, where's the person standing, and are they seeing the same thing as somebody who's standing 3 feet to the side of them?
yeah,
Um, how to create realism, bending light, bending projection, bending. Right now we have technology that's providing for very flexible display panels, EL light, or EL wire that allows you to light clothing and project things on fabric. So now we have very flexible screens, very flexible materials. I think I remember hearing that somebody was trying to take that flexible material and wrap a car in it so that you have an entire car that is now a driving projection screen, which might be contribute to distracted drivers all around the place. But still, I mean, if you're able to project something like a car, almost James Bond in Goldeneye, his Aston Martin goes completely clear against the ice, and when he drives up on the side there. So that's kind of a type of application that somebody's dreaming up. Now, getting the windshield to be completely covered as well, it will probably be the hardest part. But having vehicles and having these flexible screens that and the ability to not only capture in the right angles, but also display in the right angles. So no matter where you're looking at a vehicle, it's displaying it in right proportion. It would be a real interesting feat for projectionists and researchers to pull off in the future.
yeah. One interesting thing I saw this weekend in a hotel room was there was a TV behind the mirror in the bathroom. The bellman was like, "Hey, check out the TV in the bathroom," and I was like, "What are you talking about? There's no TV in the bathroom." And he turns it on, and it's like the screen shows behind the mirror, and I was just like, "What?" The resolution wasn't too great because I guess the technology is new, and it looked like it was like behind a couple panes of glass, like in terms of like clarity and that sort of thing. Um, but yeah, so like mirrors reflect your reflection, and now you can introduce uh, a screen there too. So I could see something like that being used in sort of like cloaking as well. So wrap it
Mm.
around something, but then have like an image behind it as well to knock out or introduce some other sort of image that you want the viewers to see.
Now, if you were interested in having your own screen or touch screen or calendar or something in your bathroom, I've actually seen tutorials where people have taken old cell phones that they no longer want. For example, if I wanted to take my old Galaxy S5, since I've upgraded to the S7, I can now change that into a touch screen or something and have it permanently mounted behind my screen, the vanity in my bathroom. And so when I go and brush my teeth, I can see what the weather is or whatever I have on my calendar. Um, but you can't really touch it and change the display because it still needs that the surface. It needs to be close enough to the surface that it can detect your finger, and it can't do that behind the glass. So, but if you wanted to have something that's permanent there, you can always do that as well.
Do you have to like shave part of the mirror or something, or
Now, the tutorials that I've seen of actually creating you'd be creating a new mirror, but some of them are you're creating a blackout area and then mounting your camera to it, plugging in your camera to a permanent power source, and run that to the plug that's next to your next to the vanity, um, which means you're eating up a plug the entire time. but it'd be something that you'd have to check out some of the tutorials that are available on YouTube and really see how it's done. I don't do it justice describing it because really I didn't pay that much attention to it. I'll admit it. But anyhow, well, that does it for our top stories of the day, or at least for this week. It is Father's Day, so I'm going to get to enjoy not spending time with my kids and go see some Central Intelligence.
You're going to enjoy Father's Day not being a father.
Yeah, exactly. My wife was nice enough to say, you haven't had a day to yourself for a while. Go take a day, and I'll take the kids. And that's actually probably the best present I could have had, is just to have some time to decompress.
Cool. Anything on this upcoming week?
Not much. Like I said earlier, I have a couple of interviews that I've been going on for new jobs, and hoping that they'll come out in the positive this week. And then just continuing to working on a couple of projects with the kids at home. We started doing our rocketry, building the rockets. Now we actually have to go out and shoot the rockets.
Cool. Definitely jealous of that. So.
Yeah, a lot of fun. But you get to see real rockets launch pretty soon.
Yeah, it's still a few months away, so but it'll be cool. Yeah.
One thing that did happen this past week, I mentioned it earlier, that I was looking up some famous people who have STEM degrees, and I found a few really, really interesting things. Rowan Atkinson, who plays Mr. Bean, I found out has his master's in electrical engineering.
Wow.
Art Garfunkel of Simon and Garfunkel has a master's in mathematics. And then Dolph Lundgren, like the world's ugliest actor on the planet, who's what was it, Rocky 3, where he plays the big Russian. He actually has his master's of science in chemical engineering.
Wow.
Yeah, and for somebody who comes across as a meathead on screen, the dude is like super smart. And then, of course, like I said, Brian May of Queen has his PhD in astrophysics. So, a lot of famous people out there recognize the need to have advanced degrees, even though it may not be their career. But having the knowledge and continue to pursue the knowledge, I think it's awesome that many of them not only did it in their undergrad or early in their careers, but like Brian May completed his PhD 30 years after starting it, after joining Queen. So, never too late to continue the education, continue your passion.
Yep. All right.
Well, that does it for us.
Yeah, I guess that wraps it up.
Thank you all for tuning in. Again, don't forget to subscribe to our channel if you haven't already. Be sure to check out our website, expeditionsystem.com. We're available on iTunes, Stitcher, and Google Play. In the meantime, I am Chris.
And I'm Andrew.
And we're out of here. Take it easy.